As the James Webb Telescope just observed artificial light on the planet Proxima b, the JWST MIRI instrument is capable of detecting large artificial light sources on distant planets. This is the first real evidence of a technosignature of probably intelligent life forms on another planet. MIRI is a high-resolution infrared instrument that is extremely sensitive to infrared radiation and can therefore detect distant metropolitan cities and industrial facilities at any time. This applies not only to our neighboring system Proxima Centauri. MIRI can detect artificial light sources and potential alien cities throughout the known universe. It sounds fantastic what we can do with our new super telescopes on Earth or from near-Earth space. We can now easily detect large settlements within the known universe. We have already achieved a masterpiece with the MIRI spectrometer at the JWST, and there is even more to come. Another mega telescope will be launched in Chile in 2028. The extremely large telescope, YELT, will once again outshine everything that has come before. With a 39M main mirror, this telescope will look deeper and sharper into space than ever before. We need these technical innovations because our thirst for knowledge about the universe is far from quenched. We are only at the beginning of exploring distant worlds, and we need instruments like the JWST and the YELT to examine exoplanets for traces of life. In addition to the ability to detect artificial light emanating from gigantic cities in space or extraterrestrial airfields, we will soon be using a new secret weapon. With the AR system, we will be able to detect traces of vegetation on distant planets. The development will go on and on. In our search for other species in space, we will use more and better instruments and tools until we have found and made contact with other life forms. The first artificial light source on Proxima b, scientists have long dreamed of this. For the first time, they're using a telescope to look so precisely into our neighboring star system that places of life become visible to us. An artificial light source on the planet Proxima b reveals the presence of technology and therefore also of some form of advanced life. It sounds crazy, but the JWST could even analyze our own activities on Earth based on our light signatures. The best telescopes of all time would easily capture the lights of major cities such as New York, Rio de Janeiro, or Beijing. With its fine sensors, it can filter out the artificial light traces of airports, large industrial plants, or even space stations from the natural light emissions of the Earth. The same is happening on Proxima b. For the first time, we will have precise analyses in our hands of where life is located there, how much artificial light it produces, and how mechanized this species is likely to be. We have thus made a quantum leap in our search for life in space, and one day we will certainly have the technical means to communicate with other civilizations. If we wanted to send messages to Proxima b, they would take more than 4 years to travel one way. By normal means, we would have to wait another 4 years for a reply to come back. All hopes are currently pinned on the development of the first quantum computers. Quanta know neither a fixed place nor a fixed time. Once we have cracked this fantastic technology, we will develop quantum means of communication and communicate with distant civilizations as if in real time. Does that sound like pure utopia to you? Then hold on tight, because utopias often become truths very quickly. Simulation of the surface of Proxima b. It was 2016 and a long way from the now very real era of James Webb when scientists dreamed of exploring alien worlds. Back then, a groundbreaking simulation predicted how the James Webb Space Telescope would study the surface of the exoplanet Proxima b in an unknown future. These simulations aim to analyze the planet's atmospheric and thermal properties. And of course, by 2016, researchers were already dreaming of finding out whether Proxima b had an atmosphere that was potentially hospitable to life. What was utopia less than 10 years ago is now reality. At that time, simulations of Proxima b's unique orbit already showed that the highly interesting exoplanet lies within the habitable zone of its parent star, Proxima Centauri. The JWST will carry out regular and comprehensive observations of the day and night sides of Proxima b. This planet orbits its star in a bound manner, just as our moon orbits us. Proxima b always has the same side facing its star, and one side is always in shadow. Reconstructions have shown that there must be extreme temperature differences between the day and night sides of Proxima b, unless the planet has an atmosphere that redistributes heat. Without an atmosphere, the day side would be blazing hot, and the night side icy cold. The presence of an atmosphere, on the other hand, would allow heat to be distributed more evenly. And this is exactly what we can now find out thanks to the JWST. The 2016 simulation showed even more. There could be a temperate strip in the border areas between the day and night sides. It sounds strange to imagine that civilizations exist on a planet that is half light and half dark, and that these beings settle on a strip that is perhaps several thousand kilometers wide around the globe. But it is possible. We need to keep opening our horizons and possibilities in the search for other life forms in space. To be really sure, we need real analysis. In 2016, the exact analyses of the chemical composition of the atmosphere of Proxima b were still a dream. Today, the JWST proves its ingenuity every day and shows us exact analysis profiles for worlds that are sometimes hundreds or even thousands of light years away. The JWST can recognize signatures of water, carbon dioxide, and methane, and has already made a find. The last comprehensive profile was obtained from the exoplanet K2-18b, where the JWST found evidence of 4 biomarkers in the atmosphere. The more such biosignatures are measured around a planet, the more likely it is that life could exist there. Particularly exciting is the potential discovery of ozone, which is considered a strong indicator of biological activity because it is predominantly produced by biological processes in our atmosphere. K2-18b could therefore be an inhabited world. However, we have not yet found any traces of artificial light there. This planet could be a pure water world, but that does not mean that it is uninhabited. We have to take into account that there is intelligent life in the water, possibly even cities, and we have to consider that not all developed species have artificial light. We haven't had the light bulb for that long, and yet humans were already intelligent and to a certain extent recognized in ancient times. The James Webb Space Telescope, JWST, is primarily designed to observe the universe in the infrared range and carry out detailed spectral analyses of distant celestial bodies. What the JWST has not yet proven is its ability to detect plant growth on exoplanets, but it does have the potential to do this. In our search for life in space, we must not only rely on technosignatures and the emission of highly advanced species. We must also look for planets that may only have plants and animals or other simpler life forms. Click the subscribe button now and be part of every new exciting video on our channel Digital Discoveries.